We're going to do a little acceleration example, and we're going to look at Mr. Lau's old college car, a 1995 Ford Escort LX, 88 horsepower. It had a little bumper and like these chrome wheels. Yeah! It's 0 to 60 in 13.8 seconds. Actually, I didn't look this up. One of my students did, because I actually have a little trick. I can actually go 0 to 60 in 2.7 seconds, which I'll tell you about later. But someone looked this up for me there. So that means if I floor it, I might be able to beat like a school bus, maybe. And we'll compare that to a Lamborghini 2002. Lamborghini M, there you go, 0 to 60 in 3.6 seconds. So we're going to solve this really quick. So anytime we're going to solve something in my class, I want you to follow 4 steps to annoy you and make your life difficult. No, not at all. 4-step process of problem solving is a way to systematically break down solving quantities of numbers or whatever to help you break down ideas. And so for now, it's going to be kind of overkill. But later on, we're going to do some fairly complex problems where if you don't have a process, you're going to have trouble. So the first step is to make a little sketch. And how does the 0 to 60 test work? You start off in your car. There we go. There's my little Escort. Actually, had a little spoiler. Yay. There we go. Whatever, right? It actually looked pretty much like a box. And the 0 to 60 test is you go to a racetrack. There's a stoplight. Stoplight's red. And then as soon as it turns what? Green, you what? You floor it, right? And your goal is you want to try to go 0 to 60, what? When we say 0 to 60. In America, we use what? Miles per, what? Hours, right? Miles per hours. Units is very important in as little time as possible. And in my case, it was a very pathetic time there. Got it? That's step 1. Not a big deal. Just try to visualize what's going on. Sometimes the picture will tell you something that you wouldn't have seen if you didn't draw it out. So for example, like on the Apollo moon problem, where the astronauts put a mirror on the moon, you shoot a laser, it bounces back. They actually really did that. The mirror is actually still there. So, but you realize by drawing the picture, the laser beam had to go there and back to divide by 2. Step 2, what do we do in step 2? We list all of the what? The information, right? So what are we trying to do in this problem? We're trying to find acceleration. So all you got to do is write A equals question mark. Okay, and you're like, do I really have to do that? And the answer is, yeah, you should. That's the goal. Put a star by it. Eyes on the prize. So you know what's going on. Later on, we might solve more complex problems. I noticed on the first homework set, some people are having trouble on some pretty simple speed equals distance over time problems. And a lot of it is because you're just not breaking down the information and you're flipping the numbers. Like, we don't want to just memorize, like, just divide by 2, right? Or just divide by the time. Like, no. Like, actually break down. What are you trying to solve for? What are we given? There's some information here. What are we given? It's 0 to 60. What does that mean? That means your starting speed is what? 0. So what's a fancy way in physics to say starting speed is 0? The starting speed we're going to call VI. What does VI stand for? Anyone know? Initial velocity. Remember, velocity is just speed with direction. In this case, it's going to be a positive acceleration, but the opposite would be if we slow down from 60 to 0. It would be a change in velocity of negative 60. In this case, it's going to be positive 60. What would 60 be? That's our V what? Our V what? F. You see that? And this is exactly what your GPS tracks as you drive along a highway to figure out your rate of acceleration, how long it'll take you to get to your destination, next turn, etc. You see that? And then what's the last thing given? The time, right? And in this case, the time was a pathetic what? 13.8 seconds. Wow! That's totally lame-o. Got it? Step 3, what do we do? What do we do in step 3? Everyone's like, man, all these steps are so annoying. And I apologize. I'm not trying to irritate you on purpose, but I am. It's actually to make your life easier later on. And actually, this helps you get the right answer the first time, which I think is actually better. Got to trust me on this one. Rock and roll. So anyway, how do we do this? Acceleration equals, what's our equation that relates our knowns and unknowns? Acceleration is just your change in velocity over time. That's the simple way to write it. If you want to expand it, your change in velocity is your V final minus V initial over time. You see that? So the math is not hard. It's just trying to get used to these new ideas. So now in step 4, all you do is you substitute in your knowns and unknowns into your equation that relates them. And do I really want you to write out the equation? I do. Because if you don't do that, people start making up their own equations. That's bad. Don't do that. And later on, we might have, actually in our next unit, we'll have actually 5 equations. We'll have some weird ones, like VF squared equals VI squared plus 2A delta X. Whoa! So if you write out the equation, you won't randomly stick in numbers. Got it? We don't want to do what I call little lotto physics. You guys ever received the lottery where like these ping pong ball machines spit out? Sometimes students come in and they do like little lotto physics. There's numbers all over the place. It's all random. So now let's plug and chug. What do we put in for A? That's A. That's what we're solving for, right? What's VF over here? 60, what's VI? 0, and the time is 13.8. We'll just put on the units at the very end. Make it a little bit easier here. So now it's going to get out our calculators. So let's punch it in. I'm going to take 60 minus 0, which is just 60, right? Divided by what? 13.8. And I get 4.347. Let's just round that off. 4.35. Okay. What are the units on this? This is kind of weird. 4.35 what? 4.35. Aha, it'll be miles per hour for velocity. And then what was the time interval? Seconds. Okay, I'm having trouble writing miles per hour. There you go. Miles per hour per second. Huh? What the heck is that? That's kind of weird. What that means is after 1 second, the 1995 Ford Escort LX will speed up to a whopping 4.35 miles per hour. After 2 seconds, it'll go to 8.7 miles per hour. You see that? Et cetera, et cetera. Now let's see for the Lamborghini. You know what? Everything is the same, but what's the only difference for the Lamborghini? Everything's the same, but what's the only thing that changed in terms of our knowns and unknowns? The time. So I'm not going to make you do the 4 steps again. That's just annoying. The whole point is, it's kind of like an essay. This is your nerdy physics essay to break it down. So in this case, let's take a look. Looks like we're given, everything's the same, but the time now is 3.6 seconds. So the time for the Lamborghini is 3.6 seconds. So when we plug and chug, the acceleration for the Lamborghini is the same. It's just going to be 60 minus 0, but it's going to be over 3.6 seconds. So let's go ahead and punch that in our calculators. Tell me what you get. If we do 60 over 3.6. Having trouble with my pen. There we go. 60 over 3.6, what do you get? A crazy number, right? The acceleration is, what does it round off to? Woo, punch it in. 60 over 3.6. Survey says, boom. So like 16.7. Holy guacamole. Miles per hour per what? Seconds. So now if you look at this, there's a way to quantify the acceleration of the two cars. Looks like the Lamborghini has about 4 times the rate of acceleration. Isn't that crazy? So if we round off 16.7, let's just round it off to 17 miles per hour per second. What that means is after 1 second, the Lamborghini can go what? Like 17 miles per hour, right? After 2 seconds, it's going what? Like 34 miles per hour, right? After 3 seconds, it's whatever, 34 plus another 17, 51 miles an hour. And then finally, after 3.6 seconds, it's going 60 miles an hour. So what's tricky is, again, the units are a little bit weird for acceleration, but if you quantify it, you can break it all down there.